So for perfect neutralization, you should not have any feedback. So y dash re should be equal to 0. What does it mean? Y re equal to yn. So the reverse admittance, whatever you compute, should be equal to whatever you have connected as the feedback component, YRE equal to YN. This indicates that oscillation does not exist if the designed circuit element YRE for all the frequency points is going to match with YN. Okay, so this is, if this you can ensure that YRE equal to YN, then you can eliminate the possibility of oscillations in your tuned amplifier. YRE is what is present inside circuit after fabrication, and YN is the component what you connect external to the circuit. So if you ensure these two components are going to be completely matching, then you can say that the circuit will not have any oscillation. And you know YRE is a non-linear YRE is going to be capacitive in nature. YRE is minus j omega into CRE. So it is a capacitively varying function which depends both on operating point and frequency. Omega, when you have a term involving omega, it is dependent. So if the frequency is changing, YRE will change. So this equation will not be valid because this equation will not be valid for all frequencies. Yn is a constant term, but YRE depends on omega. So when omega is constant, this equation will be perfectly valid. When omega starts varying, this equation validity is also not going to be true. So hence the desired component that is used for neutralization is a negative capacitor. See, the admittance is a capacitance, so you have to neutralize this. That can be done only by a negative capacitor. Since the fabrication of capacitor is complex, an inductor with negative susceptance is preferred, which has the inverse frequency characteristics. See, I want to overcome this capacitive effect. So definitely only if I use an inductor, inductor has exactly the behavior which is opposite that of a capacitor, and it can cancel out the feedback which is generated by this capacitance. So either you can use a negative capacitor to cancel out the effect of IRE, but since the fabrication of capacitor such a high frequency is not preferable or it is going to become complex, I'm going to choose an inductor with a negative susceptance. See, why negative means I want to cancel the effect. So already there is a positive feedback. I want to cancel that, so the and a negative value is preferred. Negative inductor or negative capacitor means don't think that the capacitance value, inductor value is negative. They are connected in such a way that the feedback signal will be opposite in phase. That is what they are meaning here. Okay, so don't think that negative capacitor, there is a capacitor with value minus 2 microfarad. No, it is 2 microfarad capacitor, but it is connected in such a way that the feedback signal coming from that capacitor will exactly cancel the feedback which is present in your circuit. An inductor, you know, inductor is inductor and capacitor or duals. Both can be replaced in any circuit because they have the exactly the same behavior with opposite characteristics. And also inductor is short circuit during AC. Moreover, the inductor is short circuit for AC, DC voltages, so that will become problem to your circuit. So if you are going to use an inductor, there is one problem. So you know, during short circuit, heavy current is going to flow, and there will be always a constant DC biasing which is going to be present in circuit. For all the DC operating condition, the inductor will be presenting a short circuit, so heavy current flow will go through your circuit, which may damage your circuit. So inductor is one choice, but I cannot use inductor because there is a problem with the DC. So one practical approach is to use a fixed capacitance that is transformer coupled for phase shift to produce neutralization. So I am going to go for capacitance device only, but I need to generate this minus negative phase shift. So I'm going to connect the capacitor which is going to be on the other side of a transformer. You know, in a transformer between primary and secondary or between the same windings, you will have opposite polarity, right? So if I connect a capacitor on the other side of transformer and if I take that voltage and give it to base, it will produce a negative capacitance effect. So one such circuit which is going to be helpful in neutralization is going to be the Hazeltine neutralization technique. Okay, so neutralization, the basic concept of neutralization is very simple. I have a positive feedback and I am going to make it zero. So I cannot blindly make a positive feedback signal zero. I have to add that with the signal which is equal in magnitude but opposite in phase of that signal. So I have two options to use L and C, and fabrication of capacitor is difficult, so we went with L, but L has an issue with short circuiting a DC. So we are again back to capacitance. But how to generate the negative feedback or the negative value of feedback